Hello everyone, welcome back to our college algebra. In this video clip today, I'm going to cover chapter 8. I'll be talking about system of equations. Okay, so let's start with 8.1. We're going to cover 3 sections in this chapter. Section 8.1 and then 8.6 and 8.7. Okay, that's all we have in chapter 8. So for 8.1, we'll be talking about system of linear equations. System of linear equations. Right? I'm going to introduce you 2 methods to solve a system of linear equation. They call substitution and elimination. So let me start with an example. Solve for x and y. Solve for x and y. And I have, say, 2x plus 3y is equal to -4. And how about 3x plus y is equal to 1. Okay? First of all, let me try to explain to you the name of it. Linear equation. Well, technically, for now, it's an equation of the line. Okay, linear. You graph the first equation right here, you see a line. Second equation, you graph, you see another line. We write it in the general forms of the line. But it's not really the case when you have more variables. Then actually, linear equation is the equation where the variables is of the first degree. So x raised to the first power, y raised to the first power. You don't have x squared, you don't have square root of x, and you don't have trig function like sine x, cosine x, if you learned that already. Okay, just single x with the numbers. By the way, the numbers, we call them the coefficients. Okay, so this is called the linear equation. Just a single variable and times a number. Okay, and for our convenience, I'm going to label the first equation as 1, the second equation as 2. Okay, now let me show you, introduce you the first method to solve, called substitution. Substitution. Okay. The idea of substitution method is that you're going to choose an equation and you're going to solve for one variable into the other variable, and then you plug into it, you substitute that variable into the other equation. Okay, because you choose means what? We are smart, so we have to choose an easy equation. We solve for easy unknowns. Okay, so in this case right here, I choose equation number 2, and then I solve for y because I'll do the least word. All I have to do is subtract 3x. Of course, you can choose any equation that you like. You can solve for any variable that you like. The final result is going to be the same. Given that your algebra skill is good, you make no mistake on calculation, then it doesn't matter which equation you choose, you will have the same answer. Alright, so to make it easy, I'll choose equation number 2. Choose equation 2, means the second equation right here, and solve for y. Since doing that, I'll do the least work. So equation 2. What do I have in here? 3x plus y equal to 1. Solve for y in terms of x. I subtract the 3x on both sides. I got y is equal to -3x plus 1. By the way, you see that we have a linear equation. There's a line right here. Y equals to mx plus b. Slope is -3. And intercept is 1, right? Okay, now that's for another thing. We're going to solve for y from a second equation. Of course, in terms of x, we're going to substitute that y back into the other equation. The second step, no, this is called the first step then. All right. Second step, substitute y by -3x plus 1 into equation 1, the other equation. Okay? So I got what? Equation 1 is 2x plus 3y equal to 4. So now whenever I see a y, I'll replace it by -3x plus 1. This is the same as what? 2x plus 3 times -3x plus 1 equal to 4. And then I can solve for x from here. Simplify. 2x plus, it's going to be minus because I do distribution. 3 times -3x is -9x. And plus 3 times 1 is equal to 4. 3 times 1 is 3 right here, and then we have 4 at the end. Okay? Now combine the like terms. I got negative 7x plus 2 minus 9. Now I'm going to equal to -4. I got to copy it right. -4, -4. Okay. Now I'm going to subtract the 3 on both sides. Subtract the 3 is equal to -7. Okay. So all I have to do now is divide both sides by -7. I got x is equal to 1. Divide both sides by -7. By -7, I got x equal to 1. Now I got x equal to 1. I need to solve for y as well. I can plug x equal to 1 into any of those equations that involve an x and y. Plug into the first equation, plug into the second equation, or even plug in here. I can solve for y. So y is equal to -3 times 1 plus 1. This is -3 plus 1 equal to -2. Okay, so you got x and y solved. This is how people write the answer in a 2 tuple. X, y is equal to 1 comma -2. And that means x is 1 and y equal -2. There's another reason that people usually write this way, not the only way, okay? People write this way to indicate that this is a point, okay? In the xy coordinates, right? Xy is point, okay? And let me explain to you why people think of it that way. Okay? So, but before getting there, let me go over the whole method that I just introduced you. Substitution. You choose an equation, all right? You choose, you solve for one variable. So be smart, choose an easy equation, solve an easy variable. And then, of course, it's got to be in terms of the other variable, right? You solve for y in terms of x in this case. And then you substitute that y into the other equation. And you simplify. You see what happened in here? No more y into equation 1 because you replace y by -3x plus 1. Simplify, you have an equation with just x. You solve for x after having x equal to a number, you plug it back into the other equation, you can solve for y. And try to generalize it a little bit more. Say later on you may work with a system of 3 linear equations, 3 unknowns, and 4 linear equations, 4 unknowns. The idea is pretty much similar. You just need to do more work because you have a bigger system. Say you got a system of 3 linear equations, 3 unknowns. Substitution method suggests what? You choose an equation, you solve for one unknown, now what? You have to substitute that unknown into the other 2 equations. Simplify. You're gonna go down to what? System of 2 linear equations, 2 unknowns. Okay, so from 3 go down to 2, and then come back here out of 2 equations, 2 unknown. Choose an equation, solve for one unknown, plug into the other. You go down to system, not system anymore, just one equation with one unknown. Similarly, say if you got a system of 4 linear equations, 4 unknowns. What do? Choose one equation, solve for one unknown until the other 3, plug into the other 3 equations. You have what? System of 3 linear equations, 3 unknowns, and then choose an equation out of 3, solve for one unknown, plug into the other 2. Just keep going down. So it's kind of recursive. You work on bigger system, it just takes more time, but the method is going to be the same. Okay, now let me interpret the system graphically. System of 2 linear equations, 2 unknowns graphically. Okay, and as I mentioned before, linear equation. This is what? Equation of lines. The first equation is going to be a line. The second equation is also another line. So we have a line. We have another line. Okay, so I have 2 lines, and guess what? 2 lines intersect each other. Let me make it short. Save some room. Okay. This is a line, say 3x plus y equal to 1. I don't know, I just make it random. The second line is 2x plus 3y equal to -4. So every point on this line right here will satisfy this equation. Every point on the second line right here will satisfy the second equation. And we're looking for a solution. It means what? We're looking for all the values of x and y that satisfy both lines, both equations. And what is that point? That's kind of common sense. Right? This is the common point between the 2 lines. In other words, the intersection of the 2 lines. The point x, y right here will satisfy both lines. Okay? And guess what? In our example right here, this is a point of 1 comma -2. And that's to see why we write this way. This is really a point. Okay? So, if you understand the system of linear equation, 2 variables right here as the system of lines, we have several cases. If the 2 lines intersect each other at one point, you have one solution. What if the 2 lines are not intersecting each other forever? In other words, the 2 lines are parallel. You know what? You have no solution. Okay, so this one right here, you got one solution. 2 lines are parallel, you have no solution. Okay, And when the two lines are parallel, they have the same slope. Say this. 2x plus 3y equal to 4, negative 4 in this case. And then what? I have another one. Say 2x plus 3y equal to, say, 5. So I am pretty much give you the same equation on the left-hand side, 2x plus 3y. So how in the world 2x plus 3y equal to negative 4, and then 2x plus 3y equal to 5 at the same time? In other words, 5 equal to negative 4. It never happened. So the two lines will be parallel, same slope, different y-intercept. Okay? And then there's another case which is pretty special. The two lines are on top of each other. Let me use two colors. This is my first line right here. And then the second line, use the red colors. Right on top of the first line. It's on top, okay? It means what? Two lines are the same. Now what? You have infinitely many solutions. Infinitely many solutions. Okay? What does that happen? So two lines are the same, right? So how do you write two lines are the same? I got this. 2x plus 3y equal to negative 4. What about 4x plus 6y equal to negative 8? Even though the two equations look different, but actually they're the same. You see what happened in here? I just simply multiply the first equation by 2, everything by 2. So 2x becomes 4x, 3y becomes 6y, negative 4 becomes negative 8. Really, I just repeat the same equation twice. Okay, so two lines are actually one. Many solutions. Okay. So we have three cases. Of course, there's no way that you have two lines in the flat plane going to intersect each other at 2 points. Okay, or 3 points. Find a many point. Either 1 point, no points, or infinitely many points, or many solutions. Okay. If you have a solution, we say that the system is consistent. So the first case right here, one solution or many solutions, we have this consistent system. And no solution, we say the system is inconsistent. Okay? And we even have, and this is a conditional system, is give you a solution. This one is a contradiction. This is obviously a contradiction. You have no solution. And infinitely many solutions, we say the system is an identity because the two equations are actually the same. Okay? Now, let me move on to the second method of solving for the system. All right? It's called elimination method. Method number 2, elimination. Okay? You guys see the way we organize the equations. X terms align with X term, the Y term align with Y term, and equal sign and numbers, right? And you see what? What if I want to add the two equations together term by term? You're going to have another equation. Okay? If I add the two terms together, I got what? 5x plus 4y equal to negative 3, right? 2x plus 3x is 5x, 3y plus y is 4y, and then equal, and then what? Negative 4 plus 1 is negative 3. Okay? And we still have another equation, which is equivalent in here because it's going to give you the same solution. All right? And this won't change. So, before adding, we can modify the equation a little. The question is this. What if I multiply the second equation, say, by negative 3? You guys see why I multiply by negative 3? Because I want to bring up negative 3y right here. So that when I add the two equations together, the 3y gonna cancel out the negative 3y's, and I don't have any y in my equation. I only have x. And then I can solve for x because I just eliminated y. And that was the idea of elimination method. So let's do that. So I'm gonna keep the equation 1 the same because I have what I need. 2x plus 3y equal to negative 4. And for equation 2, I'm gonna multiply by negative 3. And you see why I need to multiply by negative 3. I'm gonna match up the coefficient of y with the opposite sign so I can eliminate the y. Times everything by negative 3, okay? I got what? Negative 9x, and then minus 3y equal to negative 3. Okay, multiply everything by negative 3. This is a very common mistake when people do elimination method. They multiply the first term by -3, multiply the second term by -3, and then somehow forget multiply that number, the constant by -3 as well. Have to multiply everything by -3. And it serves our purpose. It's eliminate the y for us. And we have what? 2x minus 9x is -7x. And this is equal to -7. Of course, divide both sides by -7. You got x equal to 1. Now, after having x equal to 1, you can plug into any of those equations. We're doing substitution in here. Then you can solve for y. Say if I don't want to do a substitution, can I eliminate the x and solve for y? You see in here what? I eliminated y, right? I can solve for x. I can do the other way around. I can eliminate x and solve for y. How do I eliminate the x? The idea is pretty much the same. And I'm kind of looking for the LCD in here. So I got 2x for the first equation. I got 3x for the second equation, right? So the common divisor is 6. So what? I multiply the first equation by 3. I got 6x, right? So I'm going to multiply the second equation by -2. Times 3 here, I got 6x. Times -2 here, I'm going to have what? -6x. And then when I add them up, the x is going to cancel out. I can solve for y. Okay, let's do that. Equation 1, I'm going to times 3. See what? 6x plus 9y equal to -4. Okay? Equation 2, I'm going to times -2. And I have what? -6x minus 2y equal to -2. I'm going to add the two equations up. X is going to cancel out. 9y minus 2y is 7y. And it's equal to -14. Divide both sides by 7, I got y equal to -2. So again, you have the same answer as the previous method of substitution. It's 1 for x and -2 for y. See? But in here, I use elimination method. Okay? So the whole idea of solving a system of linear equation is what? You try to lower down the number of variables. And at the same time, you lower the number of equations. Here, I got 2 linear equations, 2 unknown, right? I eliminate y, then I have just x. Or I eliminate x, I have just y. Okay? The same idea going to carry over for system of 3 or 4 or 5. And I'll give you an example for those. And you see. Okay, let's move on. I'm going to show you another example. Solve x, y, and z. Now, system of 3 variables. 3 linear equation with 3 variables. Solve for x, y, and z. Okay? How about this? 2x minus y plus 2z equal to 6. How about 3x plus y minus z equal to 2. Okay. And then how about x plus 2y plus z is equal to 8. Okay? Solve a system of 3 linear equations with 3 unknowns. And as usual, let me label them with this equation 1, this is equation 2, and this is equation 3. Okay, now I'm going to go over this bigger example using the same 2 methods that I introduced to you before. Let's start with method number 1, substitution. Okay, recall the idea of substitution method. You guys are going to choose an equation. You want to solve for one unknown. Okay, it's up to you to choose an equation, solve for one unknown. I'm going to choose, say, equation 3. I can solve for z, for example. Or you can choose equation 2, solve for z or y, x, any equation you like. Solve for any variables that you like. I would choose an easy equation and solve for easy unknown. So I choose an equation and solve for one unknown. I choose equation 3. Solve for what? Solve for z. I mean, in here you have many choices, different choices, various choices in here to solve. Okay, for variable, any variable you like. So choose an easy equation and solve an easy unknown. I choose equation 3 and solve for z. So I got what? X plus 2y plus z equal to 8. So I solve for z means what? Interval of x and y, of course. So I'm going to subtract x and 2y on both sides. So z is equal to negative x, negative 2y plus 8. Just simply subtract 1x and 2y. I don't have to do any division, right, because I got z by itself. So minus x minus 2y plus 8, and that is z. Next step is what? You're going to substitute that z into the other two equations. You already used equation 3 and you solve for z, so don't use it again, okay? Plug into equation 1 and 2. So the second step, substitute z equal to negative x, negative 2y plus 8 into equation 1 and equation 2. Okay? Let's start with equation 1. Equation 1. We have what? 2x minus y plus 2z equal to 6. So I replace z by what I have in terms of x and y. So I got what? 2x minus y plus 2 times negative x minus 2y plus 8. Because I know that z is negative x minus 2y plus 8 equal to 6. And then simplify. You got what? 2x minus y minus 2x minus 4y plus 16 equal to 6. Combine the like terms. Oh boy, it's lucky. We got x cancel out, right? X cancel out. I got negative 5y plus 16 equal to 6. We are very lucky that we cancel out the x and we can just solve for y directly. And if you cannot solve, you still have x, then we're going to substitute into equation 2. But in here, we're lucky. So let's do what? Subtract the 16 on both sides. We got what? Negative 5y equal to negative 10. So y is equal to 2. I divide both sides by negative 5. Okay? And then what? You substitute to equation 1 already. You got y equal to 2. Very good. Now you do the same thing. You substitute into equation 2. For equation 2, we have what we have in here. 3x plus y minus z equal to 2, right? Replace the y by negative x minus 2y plus 8. 3x plus y minus what? Negative x minus 2y plus 8 equal to 2. Again, simplify. 3x plus y plus x plus 2y minus 8 equal to 2. I need to erase something right here. So combine the like terms. We have 4x plus 3y, and then add the 8 to both sides, right, equal to 10. Okay. So what I'm trying to bring to you is this: we're gonna bring down the system of two linear equations to unknown. Okay. This is the second equation that you have from simplified equation 2. This is another one that you have after simplifying from equation 1. So this is what? Y equal to 2 and 4x plus 3y equal to 10. Now all you have to do in here is what? Plug in y equal to 2, you can solve for x. Okay? So plug in y equal to 2 right here, you got 4x plus 6 equal to 10. So 4x equal to 4, so x is equal to 1. Okay? After having x and y, plug into any equation, you can solve for z. I can plug into the third equation right here. Z is equal to negative x minus 2y plus 8, which is negative 1 minus 2 times 2 plus 8. So negative 1, negative 4 plus 8, so equal to 3. Okay, so x, y, and z is equal to 1, 2, and 3. You have the solution. So we have the first method right here. You see what the idea of it. We have a system of three linear equations, 3 unknowns. Okay? You choose one of the equations of your choice. I was just lucky that I chose a good equation, so I solved quick. You can choose any equation. It's the same procedure, the same step of solving. Say I choose an equation 2. I can solve for y. What? In terms of x and z, right? So y going to be equal to what? Negative 3x plus z plus 2. You plug that y into the first equation, and the third equation you simplify. You're going to end up with a system of just two linear equations without y, just x and z. come back to the system of two linear equation and two unknown, you can solve. Okay? And same idea if you have more equation, choose an equation, solve for one unknown, and then substitute that into the other equations. Okay? That was the idea. Now, let me move on to the second method, elimination. All right? For elimination, you have to choose a pair of equations, and you have to eliminate one variable. So in here, I see that equation 2 and equation 3, I got what? Negative z right here and positive z right here. So I don't have to multiply anything. Then I will eliminate z. And if you want to eliminate z, keep eliminating z all the time.